Hi ladies and gentlemen, we are on page 11 of our pre-unit 12 packet. We are going to look at parent functions and piecewise functions. Parent functions are basically a review, but we need to understand what a parent function is. And a parent function is just the simplest form of each type of function. So we're going to look at linear parent functions, absolute value parent functions, quadratic parent functions, exponential, square root parent functions, all sorts of parent functions. So the first parent function that we have is our linear parent function, which is y equals x. So in order to graph this out, what I'm going to do is I'm going to create a table of values, and I'm going to have an x and a y. And I'm just going to arbitrarily choose some numbers to graph out. So x, I'll start with -3. And then I'll go all the way down to +3, okay? So if y equals x, then when x is -3, y equals -3. When x is -2, y equals -2, because x and y are equal to each other, okay? All right, so let's go ahead and graph out these coordinates. So -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and 3, 3. Go ahead and grab a ruler and connect your dots. And this is your parent function, y equals x. But you also know how to graph this out just because the slope is 1, because that's the coefficient in front of this x, and the y-intercept is 0, so it starts right at 0, okay? All right, so let's do the same thing for question number 2. I'm going to create a table of values, and same thing, I'm just going to go from -3 to +3. And if y equals the absolute value of x, my first expression is going to be, my first value that I'm going to plug in is -3. So I'm going to take the absolute value of -3, which is +3. To find the next one, I would take the absolute value of -2, which is +2. To find the next one, I would take the absolute value of -1, which is +1. Here I would take the absolute value of 0, which is 0. Here I'd take the absolute value of +1, which is 1. And then the absolute value of 2 is 2, and the absolute value of 3 is 3. So when I graph this out, it's going to look a little bit different. Right here, I'm going to go to -3, 3, and I'm going to put a dot right there, okay? Then I'm going to go to -2, 2, and I'll also put a dot. Draw out all your coordinates. If you notice your absolute value graph, if you remember we discussed this a little bit at the beginning of the school year, it's going to look like a V, okay? But here's the thing you need to understand. When you take the absolute value of a number, if the number is negative, it becomes positive. It's the distance away from 0. So right here, we're marking a distance away from 0, and it's always going to be a positive distance. So in this example, and when you have your parent function, it's never going to go below 0. Also, this half of your graph right here is a reflection over the x-axis of this half of the graph y equals x. And that will be true no matter what. So if, for example, if you have y equals 2x right here, then the absolute value of if you have y equals the absolute value of 2x, then it will also be reflected over the x-axis for negative values of x, all right? All right, so now we've got a new parent function, and this one is an exponential function. And there are multiple parent exponential functions depending on what the base is. So let's go ahead and do this one. And we're going to use the same values. So from -3 all the way to +3. Okay, and to figure this out, I would plug in each x value. So y equals 2 to the -3rd power. Remember, if you have a negative exponent, it means you have to do the reciprocal of your value. So it's 1/2 to the 3rd power, and 1/2 means 1/2 times 1/2 times 1/2. Well, 1 to the 3rd power is 1, and 2 to the 3rd power is 8. So this value right here is going to be 1/8, okay? So then if I do it when x equals -2, you would get y equals 2 to the -2nd power, so you get 1/2. Do the reciprocal because it's a negative exponent, and when you do the reciprocal, you end up getting 1/4. Okay, And then same thing when you've got x is -1, you do the reciprocal, you get 1/2 to the first power, so this ends up being just simply 1/2. And don't forget that anything raised to the 0th power will always equal the number 1. You go back to your multiplicative identity. So this is 1 right here, okay? All right, so now let's figure out our positive x values, what our corresponding y values will be when x is a positive value. So we would do y equals 2 to the first power. Well, 2 to the first power is just simply 2, okay? And then y equals 2 to the second power, that's simply just 4. And then y equals 2 to the third power means 2 times 2 times 2, which is 8. So now let's go ahead and graph this out. So at -3, the value is 1/8, so it's just going to be slightly above the x-axis. At -2, the value is 1/4, so it's going to be a quarter of the way up. At -1, the value is 1/2, so I'm going to put my dot right at 1/2. At 0, it's 1. At 1, it's 2. At 2, it's 4. And at 3, the y value is 8. So just like we already know, the general shape of an exponential function will look like this right here. And remember, it's going to try to reach 0, but it never will, because anything 2 to any power will never ever equal 0. It's just going to become a smaller and smaller and smaller fraction and try to approach 0, but it never will actually reach 0. So right here we've got y equals 2 to the x power, okay? All right, so our next parent function is our square root function. Same thing, I'm going to create a table of values. So I've got x and y. I'm going to go from -3 to +3. So -3, -2, -1, 0, 1, 2, and 3. So right here, I'm going to take the square root of -3, which is impossible using real numbers. So this will give me an imaginary number. And so it's not really useful to use any negatives when we're doing a square root function, okay? So we're going to cross out these 3 values. So now when I want to take the square root of 0, that's possible. You end up getting 0. So right here, this value right here will equal 0. The square root of 1 is equal to 1, so this value right here is 1. Now I get to the square root of 2, and I get an irrational number. So I don't want to deal with that either. For this type of a problem, it's a good idea to be pretty strategic about what x values you place in your table of values. So I'm going to create a different chart, okay? This time I'm going to create a chart of positive perfect squares. So my first positive perfect squares or 0, so non-negative perfect squares. So 0, 1 is a perfect square. The next perfect square after 1 is 4. The next one after that is 9. And I'm going to stop there because my graph only goes out to 10. Okay? So then when I figure this out, well, the square root of 0 is 0. We already figured that out. The square root of 1 is 1. The square root of 4, so here this is saying that y equals the square root of 4, so y equals 2. And here y equals the square root of 9, so y equals 3. So I'm going to go ahead and graph out these points. So 0, 0 will be right here, 1, 1 will be right here, 4, 2 will be right there, okay? And then 9, 3 will be right here. So that way when you graph it all out, this is what your square root function looks like. So you end up getting y equals the square root of x right there. All right, so again, with question number 4, we chose numbers, first of all, that we could even, that are even part of our domain, that we can actually find the outputs for. So we completely ignored our negative values because it's not even in the domain. Although non-perfect squares are in the domain, because if you look right here, this function is continuous. It keeps on going and going and going. So we just didn't put 2 in our chart because we'll get a crazy irrational value, but you can still include it if you want to and approximate where it should go on your graph. However, with all these other examples, like example number 3, you can use any x value you want. You can raise 2 to any power, okay? You can take in question number 2, you can take the absolute value of any number. So any x value goes here, okay? And any x value goes here because y will equal any x value that you want. So the most important thing for you guys to understand is that you have to understand when the domain is limited. In question number 4, if it says y equals x squared, x is your, what's defined as your domain. So your domain is all the x values that work. And you can square any value you want. So for this one, I'm going to create another chart, and I'm going to use the same values that I used for most of my examples, which is from -3 all the way up to +3. Okay, so y equals, the first value is -3, so I'm going to take -3, I'm going to remember to put parentheses around it, and I'm going to square it. -3 squared is 9, okay? And then the next one is -2 squared, which is 4. The next one is -1 squared, which is 1. Then I've got 0 squared, which is 0, 1 squared, which is 1, 2 squared, which is 4, and then lastly 3 squared, which is 9. Okay, so if you look right here, if I were to graph this out, this is what my graph would look like. -3, 9, right here. -2, 4. -1, 1. 0, 0. 1, 1. 2, 2, 4. And 3, 9. Okay, so this is my parent quadratic function, y equals x squared. So everything else that we graphed out in the last unit, every single quadratic function was basically this parent function with some type of a transformation done to it. And we're going to talk about how to do that in the next unit. So one other thing that I want to make sure that you guys understand is that y equals x squared and y equals the square root of x, these two graphs are inverses of each other. And if you remember, when we did our reflections, we learned how to reflect over the line y equals x. So if I were to take this graph right here and reflect it over the line y equals x, and I don't want you guys to graph this out right now, I just want you to just follow along with what's happening right here. So if I were to reflect this over the line y equals x, this point right here would stay right at 0, 0, right? 1, 1 would stay right at 1, 1. But then this point right here, when I graph out 2, 4, it's going to now go to 4, 2. Because it's going to go diagonally across, right? So this is one box across. Now it's one more box across. So this is at 4, 2, okay? And then this one right here, when I count diagonally across for this one, it will end up being at 9, 3. So this right here should look familiar to you. It's basically this graph right here. So it's just a reflection over the line y equals x. But this part right here will also reflect over and will end up looking like this, which is impossible because then it won't be a function. It doesn't pass the vertical line test, okay? So that's why, it's another reason why when we do our square root function, it's only, the parent function is only defined in the first quadrant up here, while the square function is defined in both quadrants. 1 and 2, okay? All right. All right, on number 5, it says to graph the following piecewise functions and to also find f of -2 and f of 10. So here's the thing that you guys got to do first. You have to see where your two pieces are going to be defined. So your first function you're going to use when x is less than or equal to 2, and you're going to use the second function when x is greater than 2. So what I'm going to do is I'm going to cut my graph right where it says that the first piece ends and the second piece begins. So the break occurs at x equals 2. So I drew a vertical line to represent where my break is. So then if I want to graph out my first function, I know it's a linear function because it's in the format y equals mx plus b. And I know my y-intercept is 2. So I'm going to start it at 2. And then I'm going to go up 3 and over 1 because my slope is 3 over 1. And then I'm going to go up 3 and over 1 again. And so I'm going to put my dot right here. But it's equal to 2 for the first function. So that means I have to put a closed dot on this section right here. And then I'm going to keep going with my graph. So instead of going up 3 and over 1, I can also go down 3 and to the left 1, because that'll still give you a positive slope, okay? So then when you connect your dots right here, that's your first graph, and then it keeps going on forever in the negative direction, okay? And then your second graph is f of x equals -4. This is another linear function, but it's just a horizontal line. It has a constant slope of 0, okay? So this means that I'm going to start it at -4, and then I'm going to draw a horizontal line, and it's going to keep going on forever. However, it's not equal to 2, so I'm going to put an open circle on the 2, okay? So now, how do I find f of -2? Well, I have to figure out, am I going to use the top function or the bottom function? -2 is less than or equal to 2, so I'm going to use the top function. So to figure out f of -2, I'm just going to plug it into the top equation. So I'm going to plug it in for x on top, so I get -6 plus 2, so I get -4. And I can verify it on my graph right here, because when x is -2, y is -4. And then to find f of 10, I have to figure out, is 10 greater than 2 or less than 2? Well, it's greater than 2, so I'm going to use the top function, and the top function just says -4. And then again, I can verify it on my graph right there, and it works. All right? All right, so let's look at our piecewise function for number 6. Let's analyze it first and really make sure we understand what is happening in this function. So first of all, you have to understand that there are 3 sections to this function. And the first section is a linear horizontal function, and that is going to be true when x is less than or equal to -2. So from -infinity to -2, this is your first piece of your function. And then between -2 and +3, but not including either one of those numbers, your new function is -2 minus 3x, okay? And then your last function, starting at 3 and going on to infinity, is going to be this quadratic function right here, this x squared minus 5, okay? So first thing we need to do is identify where our breaks are going to be. And our breaks will occur at x equals -2 and at x equals 3. So I'm going to go ahead and graph out a vertical line at x equals -2 and at x equals 3. And that's where my graph will break. So the first piece of my function is right here, the second piece of my function will lie right there, and the third piece will lie in this section right here, okay? So now let's go ahead and figure out how to graph this out. Well, the first piece is just a horizontal line. So it's going to be equal to 3 right here. Okay, so I'm going to graph it out at 3. And it's going to be a closed circle right on -2, because it says right here that it's equal to -2. And then I'm going to draw my arrow. So that's my first piece of my function. The second piece of my function is this one right here, -2 minus 3x. So here I know it's linear, and it's got a y-intercept of -2. So I'm going to start it at -2, and then I'm going to go down 3 and to the right 1, down 3 and to the right 1. I'm going to keep going down 3 and to the right 1. Even though it's off of my graph, I'm going to show you what it's going to look like. You need to put an open circle right here, because it's not equal to 3, okay? And then I'm going to extend it the other way. It's going to go up 3 and to the left 1, up 3 and to the left 1. I'm going to put an open circle there because it's not equal to -2 there. And then I'm going to connect my dots. So there is that function right there. And then the last function is x squared minus 5, which is a quadratic function, which means that I can't figure out what the y-intercept is and then just have a constant slope from there. So what I'm going to do instead is I'm going to make a table of values for my quadratic function. Eventually, once we start doing transformations of functions, you're going to easily be able to graph this out without a table, but at this point in time, we're not quite there yet. I'm going to include 3 in my function right here, and I'm just going to go 3, 4, 5, and see what happens with that, okay? So at 3, you're going to figure out f of 3. So you plug 3 in for x. So it'll be 3 squared minus 5, which you get 4, because it's 9 minus 5, which is 4. Okay? And then the next one, you're going to do f of 4. So you're going to do 4 squared minus 5. So you get 16 minus 5, which is 11. All right? And then the last one that you would do, f of 5, you're going to do 5 squared minus 5. So you get 25 minus 5, which is 20. Okay? So this one right here is 20. So now I'm going to graph out my function. I know that when x is 3, y is 4. So I'm going to put a dot, and it's going to be a closed dot at x equals 3 because I know that it's equal to 3 in this section right here. Okay, and then I'm going to graph out my next point, 4, 11, which is off the graph slightly, and then the next one is just way too high for me to be able to graph it out. But I know that I'm going to have a quadratic function, so I'm going to make sure that it appears to be quadratic. And then this right here is my f of x. This entire piecewise function is my f of x. The blue section is your first piece, the red section is your second piece, and then the green section is your third piece. You technically don't need this vertical line anymore here, but we just tend to include it just so that you can kind of see where all the different sections are. So this is what your graph will look like. And then same thing with this one, you don't really need this vertical line right here, we just include it so you can see what all the different sections will look like. Okay? All right, so I want you to figure out what f of -2 and f of 10 are, and then press pause before you figure that out. Come back to me to compare your answers with mine. If you don't get the right answer, then please ask me in class or in the cafeteria when I see you. All right, so f of -2 is +3, and f of 10 is 95, okay? All right, so question number 7, this time we're going to create a function that matches the graph below. So what I'm going to do is I'm going to break it up into my 3 pieces so I can see where each piece of my function is. And I know that this is x equals -1 and that this is x equals +1. All right, so I know that my sections are from -infinity to -1, from -1 to +1, and then from 1 to infinity. All right, so the first function that we have here is this linear function right here. And I know I need 2 things. I need to find the slope and I need to find the y-intercept. Well, to find the slope, I just do rise over 1. It went up 1 and over 1. So the slope of this function is simply 1. But the y-intercept, I don't know. So what I'm going to do is I'm going to extend it a little bit so I can see where my y-intercept is. And here, now you can see that your y-intercept is at, +3. Okay, so that means that the first piece of your function, there's 3 pieces. The first piece is x plus 3, okay? And it happens when x is something than -1. How do I figure out what that something is? Well, you got to look at your graph and see, do I have an open dot or a closed dot? This right here appears to be a closed dot, but it could work for this function or this piece of the function. So either piece of that function will work. So it's up to you. I'm going to say less than or equal to -1, and I'm going to say that this point is defined by this function. Okay? All right, so now the second piece of my function is this horizontal line right here. The slope is 0, and it's equal to 2. So the next piece of my function is 2. But I know that's true from -1 to +1. Now, here, when I do this, I know that since it's equal to -1 here, I'm not going to have it be equal to -1 right here. So instead, I need to make sure that this is less than. This one could be less than or equal to because it's defined and a point that could work for this function or this function. It's up to you how you want to define it. I'm going to say that it's less than or equal to right here. So that way I can say that this point is defined by this function. Again, if they share the same point, it doesn't matter which one you include it with. All right, and then the last one that we have here is this function right here. And I need to figure out, same thing, what's my slope and what's my y-intercept? So my slope, it's going up 1 over 1. So again, my slope is 1 over 1. And then my y-intercept, I'm going to extend this down here, and I see that my y-intercept should be 1. So that means that this equation is f of x equals x plus 1, when x is greater than 1. Since I already claimed 1 for this piece of my function, it can't be equal to 1 there, okay? There's a lot of material in this video. If you have any questions, please make sure you come see me for help.